Have you ever wondered about how over 500 millions of grenades are produced annually? Though simple, these small, round objects are incredibly powerful tools. Now, imagine you're holding a very small thunderstorm in your hand, just waiting to explode. Creating a grenade requires precision and planning, and creating them mass-produced requires precision too. They are produced in factories all over the world, day and night. From the smallest grenade to the big one, every single one is a puzzle and each piece fits perfectly in place. They are checked to see if they will function exactly the way they are designed to. Why, though, are so many grenades required? How then do factories make such huge numbers without making any mistakes? There's a mix of science, engineering, and mystery behind each grenade. It's the story of how these small but amazing weapons are made, by the millions each of them per year. In order to understand it all, we must go back through history. The clay grenades were the very first grenades ever made. Yes, clay. What if you threw a pot of gunpowder in battle? So, let's explore how grenades evolved from simple clay pot devices to the super powerful tool we know today. The first grenades were very simple and very terrifying in ancient China. Small clay pots made with gunpowder, known as thunder crash bombs. When lit, they blew up to a deafening boom, scaring soldiers and disrupting the enemy lines.
Grenade actually comes from the Spanish granado, which means pomegranate, which a grenade looks like. If you saw a grenade of the period, say of the 16th or 17th century, it looks very much like the bombs you see on the cartoon shows. It'd be a round ball with...
They may not look like the primitive grenades we use today, but these early grenades did start a major journey in the history of warfare. They proved people small, hand-thrown weapons could mean everything. The grenades became more and more advanced as the time went on. By the 15th century, metals superseded clay, making them stronger and more reliable. Hollow iron balls with gunpowder and lit with a fuse were used on soldiers across Europe. However, these new designs would make grenades more dangerous and more effective. They had one big problem. They weren't always easy to use or safe. Flash forward to World War I, and grenades helped save the lives of the soldiers trapped in the trenches. Fighting was brutal, and soldiers needed their own way to protect themselves quickly. This was when the Mills bomb was brought in. This weapon came with a pineapple-like surface so that soldiers can easily grip the grenade. It also had a timed fuse, so soldiers could throw it safely before it went off. It became the Mills bomb, and that changed the game, giving soldiers the means to knock out their enemies from well back without exposing themselves to danger. The MK2 grenade was created during World War II, becoming an icon of modern warfare. Working against stressful conditions, its rigid design allowed it to be easy to handle and throw. This was a fearsomely reliable grenade, and it quickly became a soldier's favorite tool for many battles. By now, there were grenades not just weapons of annihilation, but carefully engineered weapons, a balance of power and precision. It's been said that grenades are deadly, and one Marine's story highlights just how. In Afghanistan on November 21, 2010, Corporal William Kyle Carpenter was on rooftop security with another Marine when he found himself in such a situation. Kyle didn't hesitate when a grenade landed inside their sandbagged position. Moving toward the grenade, he shielded his fellow Marine from the blast. The resulting explosion caused catastrophic injuries. After he flatlined 3 times, spent 5 weeks in a coma, and underwent nearly 40 surgeries to repair his body, including rebuilding his jaw and teeth and treating a collapsed lung. He couldn't have been more surprised when his own father was the one to pull the plug. Kyle also lost one eye during his recovery. In June 2014, Kyle Carpenter became the youngest living American to be awarded the Medal of Honor for his extraordinary sacrifice. The story of his is a story of courage and resilience in the face of unimaginable odds. What led us from those early clay pots to the steel grenades of today? Constant innovation is their secret. For centuries, scientists and engineers working on explosives, materials, and the designs of grenades studied them and made them safer and more effective. In addition, they added features such as safety pins which stop these from blowing up again, and carefully timed fuses to determine when to blow off. Grenades were made more reliable, and soldiers felt it okay to use them. Currently, factories all over the world create grenades in great numbers. Whereas the handmade grenades of time immemorial were produced the old-fashioned way by humans. Modern grenades are created on machines that produce each one perfectly. There is testing, not just on every piece, from the metal shell to an explosive inside, but it must work every time.
Or RTX within the outer shell, causing a powerful explosion.
This results in a powerful, precise, and trusted military worldwide weapon. Yes, grenades may look small, but it takes a big job to make. Have you ever wondered if factories could make that many grenades without mistakes? Putting the pieces together is not something as simple as just that. The perfect handles every part of a grenade. There's not one single little part inside the metal shell or anywhere else that doesn't have to work exactly right, or the grenade won't do its job. Imagine a big puzzle with a great number of pieces. What about machines and workers building that puzzle faster than you can even blink? Grenade factories work that way. Every part is cut, shaped, and tested by special machines, and experts check it all carefully to make sure that it's safe. But here's the big question. How do they produce so many grenades in such a short time? What tools and tricks do they give you? Inside those factory doors lies a science, a machine, and a world of teamwork behind them. So let's go inside and see how they make grenades.
Silver disc with several hundred tons of pressure. Once the metal is struck, it goes into a mill where the edges are shaved smooth.
Grenades are cool, small, but their power determines the result of battles. How are these tiny, complex weapons put together with such precision? We break down how millions of grenades are made each year, step by step. The first thing you will need to do is what type of material you want to use to make your grenade casing. The casing is like a strong box to protect, so to speak. This isn't any old box. This needs to hold a big, powerful explosion that when it's done explodes into sharp pieces. And for this, manufacturers use high-strength steel. Did you know that even a microscopic crack in the steel casing could cause a grenade to fail catastrophically? During World War II, grenade failures due to poor materials led to new standards that we still use today. It is tough, durable, and can deal with the push from an explosion. Not every steel would suffice. Every batch of steel is tested in factories for weaknesses or cracks.
I don't know. Because everything is shaking for it, you know? Yeah, it's like it's the same.
Supposed to pick a perfect apple from its basket. You look for bruises, soft spots. Like X-rays and stress testers, the steel is also checked through machines. The slightest of flaws may cause the grenade to fail or go past safe. Because the quality of the material directly impacts how the grenade will work. It is so important. The casing could not hold an explosion if the steel is not strong enough. The grenade will not break apart into fragments, which are important to the grenade working properly if it's too strong. Then, when the steel passes all its tests, it's time to shape it into grenade casings. It happens in massive, heavy factories, full of heat and very heavy equipment. Small pieces of steel are cut from sheets of steel and are then heated so that they glow bright orange. At this point in time, the steel is still soft and malleable, like clay is. Large machines press the heated steel into the shape of a grenade casing. The machines hit the casing with loud clanging as they stamp it out. The hot steel cools down and then steam rises from the precision process. The casing is not a simple, round, smooth shell. Grooves or patterns are often put onto grenades, imitating a pineapple. The grooves give the casing some control to how it breaks apart in an explosion. These patterns spread the shrapnel so efficiently without these patterns. Once on top, skilled workers and engineers check each casing to make sure the grooves are perfectly in line. The grenade will not function as expected if they are even an inch off. One example of real-life story shows how critical these efforts are. Thousands of women collectively became Rosie the Riveters for American factories that took on roles traditionally held by men during World War II. Among them was Gladys M. Kammer, whose obsession with detail made her famous when working her way through munitions. Gladys once flagged an imperfection on a batch of grenade casings that, if not taken care of, would have resulted in failure in the field. Her vigilance saved countless soldiers' lives.
Is entirely different to the grenades of the Allied forces and was even nicknamed the potato masher by some,
Cautioning the equally significant but unseen hands hidden behind the production lines that manufactured everything from R rifles to grenades to gas masks to tanks, which just as vitally helped win the war. Next comes the heart of the grenade, the explosive material. That is what makes the grenade so powerful. The use of high-energy explosives such as TNT or Composition B, because they provide a lot of energy in a controlled way. One of the key breakthroughs in explosive filling came in the 1960s when scientists discovered ways to stabilize TNT, reducing accidental detonations during transport and handling. This innovation has saved thousands of lives in factories worldwide. This is a step like blowing air into a balloon. It's important not to overload it or to remove it altogether. Each grenade, however, is checked by machines, which measure the exact amount of explosive material needed. It could not be too unstable, too explosive, or too little. Automated systems are used to pack the explosive material into the casing. This is done to accomplish precision and safety. Special protective gear is worn by workers who monitor the process closely. The exploding cake is frosted in layers of explosive that are clumsily spread, like frosting from left to right. But the explosive layers are placed very carefully to guarantee even distribution. During this step, safety is the top priority. Grenades are filled in the factories. There are strict safety protocols which ensure the health of the people who fill the grenades and the environment. There are also those special rooms to house any accidental explosions. During World War II, fuses for grenades and other explosives were so critical to the war effort that they were often assembled under strict secrecy in underground factories to prevent sabotage. Some of these facilities were so well hidden that they weren't rediscovered until decades later. Imagine stumbling upon a secret bunker filled with machinery that once produced the very tools soldiers depended on in battle.
You know what I mean?
Well, I steal it, it's stealing, and you steal it, it's what?
The next thing to add is the fuse, the brain of the grenade. Throwing the grenade triggers a fuse which dictates when the grenade will explode. Fuse assembly is such an overcritical process that you really need to be precise. Each component of the fuse, striker pin, delay mechanism, and safety features is built by engineers. When the striker pin hits the fuse, that's like a little hammer, which strikes and burns the fuse. The grenade uses the delay mechanism so that the user has a few seconds to throw it. Assembling a wristwatch is pretty much how this part of the process works. The grenade has to fit every piece perfectly, then it's just going to work. Specialized tools are used to place each component in care by workers. At this stage, the safety pin and lever are added to the grenade to keep it stable until it's ready to be used. And every fuse is repeatedly tested to ensure that it works perfectly well. If the fuse shorts, the grenade will either go off too early or not at all, both of which are somewhat dangerous.
Get away! Get back!
This step underlines how talented and experienced the workers performing are in this process. The final step is to put all that together and test it out. All the parts, the casing, the explosive, the fuse, are combined to make a complete grenade here. After that, grenades go through a rigorous testing series. The tests emulate real-world scenarios to make sure the grenades don't miss a step. And they are then through from heights, exposed to extreme temperatures, and spun around to check their stability. The timing of the grenade's explosion is one of the most critical tests. The delay mechanism must function exactly right, allowing the user to toss the grenade before it will go off. But if you're not really much in sync with the timing, then it is potentially dangerous to yourself if you use that grenade.
Guys, what are you, crazy? It's just a dummy grenade!
People that do these tests are highly trained. It shows that they know why they're there and what it means on the battlefield. Ready for use is written on each pass of a grenade. If things fail, they are disassembled, taken apart, and recycled. Grenades are brilliant architectural marvels, but there are some important questions implied by them. They are these small weapons meant to save lives and protect soldiers from combat. However, if irresponsible, they can cause harm. By understanding the process of manufacturing the grenade, we can better appreciate the amount of skill and effort that goes into the making of a grenade. It also makes us remember that the responsibility to make and use such powerful tools is not an easy thing. The process of creating grenades is carefully designed from the moment you decide on the perfect steel to the point of extensive and rigorous testing. Inside each grenade is a team of skilled workers, machinery in a high degree of technical sophistication, and safety measures the strictest. Having learnt a little about how grenades are made, we now look more closely at the role of grenades in modern warfare and how technology continues to modernize them. How grenades are made has changed completely due to technology. Today's factories are sprinkled with robots and high-tech tools, and have the ambience of a science lab. They're not the robots you see in the movies. They don't walk or talk. They're super smart. It is programmed that they would do the most dangerous job, handling the explosives. What if that machine was as steady as a surgeon's hands and could never make a mistake? That's just how grenade factory robots operate. The biggest benefit of robots is they are safe. Robots don't get tired or distracted as we do, and for hours they can work, measure, and assemble each part of a grenade with precision. Imagine a robot like a baker piping, caking, a fun decoration on top of the cake. It is perfect, right down to every swirl of frosting, and the materials these robots are working with can blow when handled the wrong way. Also innovative are the use of new materials. Once you had to make whatever you wanted with heavy steel, so now engineers are experimenting with lightweight polymers. Like grenades, these materials are just as strong but much lighter so soldiers can carry them. Factories are also using advanced sensors and cameras to inspect each grenade. These tools are like super-powered magnifying glasses, catching tiny flaws that the human eye might miss. Workers and engineers team up with these machines to make sure every grenade is flawless before it leaves the factory. But the more grenades become easy and cheap to make, the more important questions arise. We're producing more grenades because robots and new materials are making the whole process faster and more efficient. But should we? Then, how do we make sure these powerful tools are being used responsibly? Grenades are intended to be used for people, but they can damage as well. As technology improves, we must ask, whatever might be our merits, might we devise weapons more safe and even more moral? Engineers and leaders everywhere are grappling with these questions. How to obtain dividends on future energy demand while balancing responsibility. These are our advancements, but they're also our reminder of just how powerful and responsibly we really are. We'll now dissect the cultural and moral questions of grenades. How do they change society, and what do we learn? Grenades are not just war tools, they mean much. In pictures, grenades, for instance, are exciting and powerful. They throw them, and that is what appears to be lighting up the screen. On the other hand, grenades in real life mean something totally different. They're symbols of fear and destruction for most people. They are used to scare people, hurt civilians, and destroy homes in some parts of the world. Questions involving the making of grenades do so as well in regards to the Earth. Grenade manufacturers require lots of energy and materials. It may be hazardous to the environment. Consider logging trees for paper. Once they're all gone, they don't just grow back. It happens in factories that mine materials for grenades too. It damages the planet. But how can we protect the Earth and stay safe? There is also a human cost. Grenades are intended to protect soldiers, yet in crowded cities they often wound civilians. Think about the misery of one filled with hatred having touched off an explosion that causes you to lose your home or a loved one. Many organizations around the world are asking, how can we make grenades only target danger, not people anymore? Last but not least, grenades can join or break. They are seen in some as a tool of defense, and by others as a sign of violence. Conversation around how and why we use them begins because of this difference of opinion. Grenades are an interesting object. They have made an incredible journey since their inception in ancient history to the version you're seeing now. Yet they are powerful weapons to protect soldiers, but also quite destructive. But these things are simple, yet they do so much damage. Throughout this video, we've seen how to pick the right materials to make a grenade, and how to test that grenade. We also discussed how the weapons are not only weapons, but they're symbols as well. Grenades explode in big, dramatic ways. Yet in the real world, a grenade can harm a lot of innocent people. In cities. So, what do you think? Are grenades just a necessary part of war, or are they a symbol of violence that shouldn't exist anymore? It's a tough question to answer. Grenades are part of history, but they also raise serious problems for our future. We want to hear your thoughts. What do you believe is the right way to think about grenades? Let us know in the comments below. And don't forget to like and subscribe to our channel for more deep dives into the world of weapons and how they shape our world. Your voice is important, and we can keep this conversation going. Thanks for watching.